Okay, welcome to our first day of factoring review, which is going to start our discussion of rational functions. So this is really a review. It truly is. You know everything or you've done everything in this before. But we're going to go over and give some sort of examples of how to do these problems. Now I'm going to switch to the very back of this. Perhaps I should have put this in the front, but if I go to the back, the last page of this set of examples, you're going to see a factoring flowchart, and I'm going to put this on Canvas as well by itself, but it's here, and these are the steps you need to look for. The first thing you always look for is the greatest common factor. Then you look, after you've done that, are there 2 terms, 3 terms, 4 terms? And then based on whether there's 2, 3, or 4 terms, you have other steps or you figure out what you need to do from there. So if we look at our first one, if you notice before we flipped over here, if the first 2 problems have 2 terms. So then we're looking, is it a difference of squares or is it a sum of cubes or a difference of cubes? Well, sum of cubes and difference of cubes are tomorrow or next lesson. So we know it's not one of those. So we have to see if it's a difference of squares, which means we have a term on each end that we can take a perfect square root of and a minus sign in between. If there's a plus sign, it's not a difference of squares. Difference by definition is a subtraction. So let's go back to that first problem. And you see there is no greatest common factor between 4 and 25, and it is a difference of squares. The square root of 4x squared, if this is a squared, in other words, if 4x squared is your a squared, and this is your b squared 25, then that's going to factor as a minus b times a plus b, and that's the pattern that you need to remember, and you need to memorize it. Okay, so the square root of a squared is a, so a in this case is going to be 2x, and b in this case will be 5. Square root of 25 is 5. So then by this pattern, and this is the easiest factorization problem you get if you remember the pattern. The pattern then is 2x minus 5 and 2x plus 5. And then that's your answer. That is factored completely. Once you get down to linear factors or factors that have just the highest, an x in them, not an x squared or an x cubed, just an x, then you're done. Okay? So that's your difference of squares factorization. You have to be able to take a nice even square root of each of those 2 terms. Now let's look at 2. 2 does have a greatest common factor. The GCF of this one is 4x. That means what is the largest number or combination of numbers and variables that I can divide both things evenly by? Okay, and so what do they have in common? What's a common factor that I can divide by? So if I divide each of these by that common factor, which is 4x, your answer then, you're going to write your greatest common factor in front, and then what you get when you divide is what goes in parentheses. So 16 divided by 4 is 4, and then x squared over x is x. And then 4x over 4x, anything over itself, is 1. And so again, I'm down to linear factors. There's only x's, there's not any x squareds. And if you notice, when you distribute 4x times 4 and then 4x times 1, you get back to your original problem, which ultimately your answer of this is not an answer, it's not a solution. It's factors that will multiply back to give you your original problem. That's what we mean when we say factor completely. So that's your first 2 examples. Factor out a greatest common factor, and in this case, they both had 2 terms. So let's look at our next set of examples. And with these pages. If you know how to do these, you don't have to keep going. You can skip that example, fast forward. If you need to stop and think about it a while, stop and think about it a while. If you've got factoring down pat, go straight to the homework. These videos are here to help you if you need them. All right, so there is no greatest factor. We're on number 3 now. So there's no greatest common factor. I'm going to write that up here. There's no GCF. And there's 3 terms. So then if you look at your chart, we look to see, is there a number in front? Well, there's in front of the x squared, there's just a 1. If there's nothing written there, it's understood that it's a 1. We usually can factor these in our head. In fact, if we know our multiplication tables, we can factor these without very much effort. But let's go through and talk it through. So we're going to put 2 sets of parentheses. And we know the way to get x squared is x times x. So that's the first thing in each set. Now what else goes in there? We look at the second sign in our original problem. Since it's minus, that means our 2 factors are a plus and a minus. They're one of each. If it was a plus, they would be the same sign. But that's minus, so that means the only way to get a minus is multiply a positive times a negative. In this case, because we're only multiplying 2 things together. Now, if you want to, you can think of it in your mind, or we can go ahead and write our x. And if you write your x, and if you take time to do that, remember what goes in here is your a times your c. And in this case, a is 1. And c is -6. That's your first term and your last term, just the numbers. And what goes in here is b, which in this case is -5. And then you need to find your 2 numbers. You're going to find the number that goes here and the number that goes here. So you're looking for 2 numbers. And I'm writing this out and taking a little time. And those 2 numbers have to multiply to be a times c, which in our case again is -6. And they have to add to be b, which in this example is a -5. Well, okay, what 2 numbers add to be -6? We've got to have, so we can have a 1 and a -6, or we can have a -1 and a +6. Those both multiply to be -6. When I add those 2 numbers together, which one will give me the -5? That one, okay? So, in other words, the negative is going to go here. The -6 goes in this factor, and the 1 goes in this factor. And if you FOIL these out and check them, they will give you the answer. They'll go back to the original problem. Okay? Now, the only thing that's missing that I haven't included is where'd that y come from? Okay, we've got to deal with that y. Well, how do I get y squared? Y times y, right? So I'm going to put a y here by the 1 and a y here by the 6, okay? So let's FOIL this just to double check and make sure it gives us our correct answer. The first terms are x times x, so that's x squared. Then the outside term is minus 6xy. That's multiplying this x. So here's your first terms, x times x. Then we have the outside terms are the x and the 6y. Then the inside terms here are x times 1y, so that's plus 1xy, and it doesn't matter whether I put xy or yx. And then the last terms in each parentheses are the 2 y values. So that's going to be y times y, or negative 6y squared. And then these two numbers will add to give you the negative 5xy. So it checks that when we multiply, we get the correct answer. We go back to our original problem. Now, the only thing I would say is when you write your final answer and clean this up, now I'm going to erase all these extra marks I made. I would say you don't have to write this 1 because it's understood if there's just a y there, that's a 1y. If you write a 1y, I'm not going to count off, and I doubt that Miss Lovell would either. But it's not necessary to write the 1. So this would be your final answer in its best form. Okay? So now let's look at this. Again, we have 3 terms, but this time we have a greatest common factor. The number that these will all divide by would be divisible by 7. 7 is a factor of all those numbers. So when I divide everything by 7, remember you have to write the 7 in front. And you're going to be left with x squared plus 4x plus 3. Okay? Now again, there's nothing in front of the x squared now. Once I factored out that greatest common factor, it's just 1x squared. So I'm going to write the 7, and I'm going to write the 2 sets of parentheses. The way to get x squared is x times x. Then you look at the last number, or the last sign, here, and it's positive. That means that the signs of your factors are the same. They're not one of each. They're not a positive and negative. They're either both positive or both negative. So once you know that, you look at the first sign, and that tells me that they are both positive. Okay, so I know that I have x plus in both factors. That 7 has to still carry down that I factored out to start with. Now what goes in those blanks after the plus signs? Well, a times c here, remember, and b here. So in this example, that's 3 times 1 or 3 and 4. And the two numbers that multiply to be 3 and add to be 4 are 3 times 1. So 3 times 1, 3 times 1 is 3, 3 plus 1 is 4. And so that's your final answer, your final factored form of the polynomial that you started with in your problem. Okay, let's go on to our next set of examples. I have 9 examples. Again, watch as many or as few as you need to understand what we're doing. Now, I've already written up here at the top that the greatest common factor of number 5 is 8x. So let's go ahead and divide everything by 8x. So we're going to divide everything by 8x. So that means our first term, we're going to have our 8x in front, and then our parentheses, and we're going to have an x squared, because 8 over 8 is 1. And then 48 divided by 8 is 6x. And then set x is cancel in the last one, and 72 divided by 8 is 9. Okay. So now, knowing what we know already, we have a 1 in front of the x squared, so we make our 2 sets of parentheses. The way you get x squared is x times x. We know from this that the signs are the same inside the parentheses, And we know from this then that they are minus. Okay. Now we need two numbers that multiply to be 9 and add to be 6. And that would be 3 plus 3. 3 and 3 multiply to be 9 and add to be 6. So that's what goes in your parentheses. Okay. If I multiply that all out, I get back to my original equation. Now, this can also be written 8x times x minus 3 squared, because that x minus 3 occurs twice, and so that factor is squared. I think it's better in this, as we're coming into rational functions, to list them all out completely, because when we multiply and divide to simplify, you're going to have to cancel factors. And so if you have them written with an exponent, sometimes you might miss a factor that you could cancel. So I would leave it all written out. And if Ms. Lovell has a preference, she will tell you what that is. All right, let's look at number 6. Again, we've got that XY thing, which always adds a little level of complication, but there is no greatest common factor. And there are 3 terms. All right, well, if we go back to our flow chart with 3 terms, if there's a number in front, we have to use a process of some kind. And there's 2 processes that I usually will teach students, and one is the box method and one is grouping. And so we're going to look at both of those, but before you do either one, you have to decide what your 2 numbers are that that you need for your factors to help you factor. So let's start with our x. And remember that what goes in here in the top is A times C. Well, in this case, A is 3 and C is 20. So it's a big number. So now we've got 60 in that top part. And in the middle, the bottom, the B number is -7. So that's going to stay the same. So we need to figure out what will multiply to be -60. Should have made that negative. And add to be -7. Okay, well, let's think of factors. How do we multiply to get 60? We have 60 and we have 1. 60 times 1. We have 30 times 2. We have 20 times 3. And these are going to be 1 of each sign because this is negative. So we know that 1's going to be plus and 1's going to be minus. So that means they have to be 7 digits apart. Well, none of those are. Let's go on. We have 15 times 4. That still won't do it. Let's try 12 times 5. Those 2 numbers are 7 digits apart. Well, which one has to be positive and which one has to be negative? I have to end up with a -7. So it must be that I'm going to have a -12 and a +5. That's the only one. That's the only 2 numbers that will multiply to be -60. But when I add them, I get -7. So now we go through our process. So the process for grouping is you write the first term, and I'm going to go ahead and write it just like it is down here. So we have 3x squared minus 7xy minus 20y squared. Okay? All right, so the next step is we're going to split them. We've split the middle term. We've decided on our 2 numbers. So the first term, the 3x squared, gets written just like it is. Okay. Then instead of negative 7xy, I'm going to minus 12xy plus 5xy. Now, stop a minute. Does that add to be negative 7xy? Yes. So I haven't changed anything. I've just made it two numbers instead of one number. And then I still have minus 20y squared. Okay, so we split the middle term. Then this is called factored by grouping. So you group the first two numbers together and the second two numbers together. Okay. So you split, then you group, then you factor out the greatest common factor from each group. You might want to write these steps down. So the greatest common factor in this first group is a 3x. So you factor out a 3x, and you're left with x minus 4y. And the greatest common factor in the second group is a 5y. So we factor out a 5y. And we're left then with, remember that number goes in front, inside parentheses, we're left with x minus 4y. And if this is factorable, you're going to end up with those parentheses being the same. Okay? So now we've got two terms. We've got this term and we've got this term. And the common factor that they each have is the x minus 4y. So we factor out an x minus 4y and we put that in front. And you divide by x minus 4y. In both these terms. So this cancels and this cancels, and you're left with 3x plus 5y. And then that's your final answer. Okay? Now, rather than showing this last step, you can realize, if you realize, one of the factors is what's in parentheses, but you only write it one time. You don't write it twice because you factor it out. And the other factor is the numbers that are in front of those parentheses. That's the greatest common factors that you factored out. And so I'll show that shortcut without showing the step in the next problem. But I want to take a minute and show you the box method. Now, if you don't like the box method, if you know what I'm talking about, you don't like it, fast forward to the next problem. But with the box method, what you do is you draw a box, okay, and you put your first term here, okay, and you put your last term here. And you put your two values that you discover, with your x in here, your x values in here and in here, okay? So, drawing this box like we would do it, the first term was 3x squared. Okay. This last term was minus 20y squared. And we had two terms that we discovered, and one was negative 12xy, and the other one was 5xy. Those are the two numbers when we drew our x that we figured out we needed to solve this problem. Okay, so now just like a Punnett square in science, you're going to think, well, how can I get 3x squared? And you're going to put the number on the outside of that square. So you multiply to get what's inside the square. So in other words, the way to get 3x is 3 times 1. So I'm going to put a 3x and an x. Okay? 3x times x is 3x squared. Now, I need to put a number here. Okay, and I'm going to multiply that number by the number that outside on the left, which is 3x, to get the negative 12xy. Well, that would be negative 4y. And those numbers multiply there and there to fill in this box. So negative 4y times 3x is negative 12xy. And the number you're going to put out here on the bottom, you're going to multiply the x times the number here, and that's going to be a 5y. X times 5 is 5xy. And then the last check is you multiply to see if those numbers get you this, do this 5y and the negative 4y give you negative 20y squared, and that does. So we've done this correctly. So then you look, this is a plus. This is one of your factors, 3x plus 5y. And the other factor is your x minus 4y. Okay? And that's exactly what we came up with using the grouping method. So you can use grouping or box, either one, it doesn't matter, to solve your problem. Okay? All right, so let's move on to some more examples. 7 and 8. Now these have 4 terms. 4 terms, you automatically, after you do your greatest common factor, you factor by grouping. Well, looking at number 7, there is a greatest common factor, and that would be 4. Okay, so we're going to first factor out that 4. Every one of these numbers is divisible by 4. So you're going to factor out the 4, and that leaves you with 6x cubed plus 2x squared plus 3x plus 1. Okay? Now we're going to factor by grouping, which means, really, I'm just going to work with this right now. Well, I've got something on the screen that I don't know how to get rid of. Here we go. Okay. So, let's look at, the 4 has to show up in our answer. So I'm going to put the 4 here, and we're going to end up with at least 2 sets of parentheses. We could end up with 3, since it's an x cubed. But let's just look and see what we've got. So I'm going to work with just this part right now. So we're going to group. So you have 6x cubed plus 2x squared. I don't have to find my 2 numbers because I've already got 4 terms. Plus 3x plus 1. I grouped the first 2 together and the last 2 together. The greatest common factor of the first group is 2x squared. So always write your greatest common factor in front. And then that's going to divide and give me 3x plus 1. Okay, if there is no greatest common factor, I want you to write a 1 in front. So in other words, this has no greatest common factor. So I'm going to put plus 1 times 3x plus 1. Okay? Now, remember what I told you. You can look at these and say, okay, one of my factors is what's already in parentheses, but I only have to write it 1 time. So that's one factor. And the other factor I know is the number in front that I factored out, which are those numbers I just put in green. So the other factor then is 2x squared plus 1. All right, now I've got an x squared term and a factor. Is that a difference of squares? Because with two terms, I can only factor it if it's a difference of squares or a difference or sum of cubes. And it's not a cube, and it's not a minus sign, it's a plus sign, so it's not a difference of squares. So we have our two answers are 3x, 4, you have to have the 4 in front, 3x plus 1, and then you're going to have 2x squared plus 1. And that'll be your final answer. You cannot factor that any more. Okay? So let's look at number 8. Number 8 again is 4 terms. This time, there's no greatest common factor, so we're going to look at it just like it is, but we're going to group the first two and the second two. So there's the first two. Now, I like to make this a plus and negative. When there's a minus sign here in the middle, make that plus -5, because I want to leave a plus between the factors and put the negative inside the parentheses. So go ahead and change that -5 to plus a -5. All right, so let's look now. What's the greatest common factor in the first group? They're both divisible by 6, and both have at least 2 x's. So they both have x squared in common. So once I factor out the 6x squared, I'm left with 5x plus 3. Now, 5x plus 3 is not really the same as -5x minus 3, but I could factor out a -1 from there, which means I put a -1 in front, and now I have 5x plus 3, and the parentheses are the same. What's in parentheses needs to be the same. Then, like I said, one factor is what's already in parentheses. That's your 5x plus 3. And your other factor are the numbers found in front of the parentheses. So when you write your answer then, you're going to put parentheses 6x squared minus 1. And then in your other set of parentheses, it will be 5x plus 3. And then that's your final answer. Now, looking at the 6x squared minus 1, there is a minus sign. It could be a difference of squares, except you can't take the square root of 6 and get a nice even number. So even though it's got two terms and a minus sign, it is not a difference of squares either. So now let's go to our very last example. And there's 9 examples. Again, 4 terms. Again, no common factor. And again, a minus sign in between. So let's split it up. Groups of 2. 2x cubed plus x squared. You want to put them in descending powers of x. Highest power of x to the lowest power of x. Now remember I said we're going to make this plus and negative. So I have plus, and then the negative goes inside the parentheses. Okay. Greatest common factor of the first group is just an x squared. Okay. Which leaves me, when I divide, 2x plus 1. And then here I can factor out a -9. And when I divide by -9, you're left with 2x plus 1. So your two factors are x squared minus 9, the numbers in front of the parentheses, and then the numbers inside the parentheses, 2x plus 1. But now let's look at this right here. That is a difference of squares. I've got two terms, I've got an x squared, and I've got a minus sign, and I can take a perfect square root. The square root of x squared is x, and the square root of 9 is 3. So this will factor as x minus 3x plus 3, and then you still have 2x plus 1. So this one can break down into 3 linear factors, which you're going to end up with 3 answers when you solve a cubic equation, something with an x cubed, but you don't always end up with 3 distinct factors. Okay, that sums up this first reminder of factoring. We've done all this year, but I know you forget, and I know some of you still struggle with factoring. So you'll have a homework on Delta Math, and then I want you to be ready to learn about differences and sums of cubes next lesson. And your factoring flow chart, again, is on the back page, and I'll flash it up here again. It's on the back page of this presentation. Okay?